Let's try to solve this question here. Determine the equivalent capacitance between point A and B for the group of capacitors connected as shown below. So take C1 to be equals to 5 microfarad, C2 to be equals to 10 microfarad, and C3 is to be equals to 2 microfarad. So equivalent capacitance means by if you replace it with one single capacitance, what will be the capacitance? Okay, so here we have 7 capacitor. If we choose to replace this group of capacitors here with one single capacitor, what will be the capacitance of that capacitor? So that's the idea of equivalent capacitance. Okay, so it's in between A and B. So what we need to do, we need to combine these capacitors step by step until we are left with one single capacitor. So once we know the capacitance of that one single capacitor, that will be the equivalent capacitance. So this question here, I choose this question to discuss because I would like to highlight to you how we should, how there's no correct way of doing this, but my way of keeping track of which capacitor have we combined, which capacitor we haven't combined. Okay, so my way of doing it is to sketch and also be very clear with the subscript. Okay, so I know that my situation will start with something like this. Okay, so this is my initial situation. It's actually, there's a lot of capacitor to draw. Okay, so they label it as C1. Okay, so we choose to follow their way of labeling. So when we merge, we have to be very clear how we write what we have merged. Okay, so what we can do now is we can choose to merge C1 and C1 together. They are connected in series, so we can merge them together. C2 and C2 are also in series. This pair, we will merge them in series as well. Whereas this C2 and C2 on the side over here is connected in parallel, so we will merge them in parallel. So we are going to do 3 merging simultaneously. Okay, so the effect of us combining these 3 pairs together will be, we still have C3 in the middle, that's still the same, but C1 and C1 will be combined to be one single capacitor. C2 and C2 will be combined to be one single capacitor. Then the C2 and C2 will also combine to be one single capacitor. Okay, so how should we keep track of which capacitor that we combine? C1 and C1 we combine. So what I usually do is I will write it as C11. So it means when we merge 1 and 1. Okay, so C3 remain as C3. So this one C2 remain as C2, we merge them together, so we call it C22. Okay, whereas this one C22 also, here is where the confusion will arise. Because here there's C22, here there's C22. If it's possible, we don't want to use any symbol which are identical to represent two different things. So let's prime it to show that it's different from this C22 over here. Okay, then next, what are we going to do? We are going to merge C11, C3, and C22 together. 3 of them are in parallel. We are going to merge them together. So now we are left with a very much cleaner combination. This one will be a merge between 1, 1, 2, 2, and also 3. So we will write as 1, 1, 2, 2, 3. So this one will be C22 prime. Okay, then lastly, we'll continue. Let's continue down here. We have A and B with only one single capacitor in between. So this will be a merge between C11223 and C22 prime. So we can call it as C112222 prime 3. Okay, essentially it's just CAB lah. That's what we get at the end. Okay, so once we have a very clear picture of how we are going to merge things together along the way until you reach one capacitor, then you proceed to do your merging right now. Okay, so right now C1 and C1, they are in series. So to merge them together, C11, merge them in series. That means by you do 1 over C1 plus 1 over C1. Then you are going to inverse the answer because there's actually a 1 over C11 over here. So you bring over the 1 over to this side, so you have -1. Okay, so substitute 1 over C1. Okay, I'm taking a shortcut by not writing down the times 10 to the power -6. I'll just write micro. plus 5.0 micro. Okay, -1. So if I do my calculation, you get 2.5 microfarad. So this will be C11, what we get after merging C1 and C1 together. C3 remain the same, so we will not touch C3. We will touch the merge between C2 and C2. Okay, C22 is also in series, so we'll merge them through the series calculation. So this one 1 over C2 plus 1 over C2, invert it. So 1 over C2 is 10 microfarad. So we do it 2 times 10 microfarad. Okay, if you perform a calculation, you get 5.0 microfarad. Okay, then lastly, we still have the merge between C2 and C2, but this one you get C22 prime and it's parallel. So parallel to connect parallel, to merge them in parallel is just C2 plus C2. So if you calculate it, you get 10 micro plus 10 micro, you get 20 microfarad. Okay, so these 3 calculations here allow us to merge from this diagram to become this diagram. But now we want to go further by merging C11, C3 and C22 together. So these 3 capacitors are in parallel. So if you want to merge them together, you just use a simple addition to add them together because they're in parallel. So this will be C11 plus C22 plus C3. Merging them in parallel means you just add them up. In series only, we need to do this complicated inverting. Okay, if it's in parallel, it's just a simple addition. So C11 is 2.5 micro, C22 is 5.0 micro, C3 it's 2 micro. So if you add them up, you get 9.5 microfarad. Okay, so this is us merging them to become C11223. Okay, so now we are going to merge C11223 and C22 prime together, and because they're in series, the calculation has to be the slightly complicated calculation. C112222 prime 3 will be equals to 1 over C11223 plus 1 over C22 prime. Okay, so substitution 1 over 9.5 micro plus 1 over C22 prime, we get it from earlier, C22 prime is 20 micro. Okay, so if you perform your calculation, you get a fraction which is 19 over 295,000, which you convert to decimal, it will be 6.44 microfarad. Okay, so this is us merging C11223 and C22 prime together to get C11222 prime 3. Okay, and we know there's only one single capacitor left. So the capacitance of this capacitor will be the equivalent capacitance between point A and B. So we know that C between A and B will be equals to C112222 prime 3. That's why the answer will be 6.44 microfarad. Okay, so that is us merging this group of 7 capacitors step by step until we are left with one single capacitance, and from there we determine the equivalent capacitance. That's it for this question. Thank you very much.